Hi, I am Dikshit. If you are starting or already into embedded Linux domain, when you hear Yocto project or its terms for the first time, you might get overwhelmed like I was initially. Over these years, after getting hands-on into the Yocto project, I understood that actually Yocto project is fairly simple if you have a conceptual idea of it in the simple terms where you can relate it to before getting started and deep diving. It will really help in building a foundation to understand it from the very base. So here in this video, I will try to explain the Yocto project in the very simple way without going in the low level details what it is and its components. Before starting to understand Yocto project, let's first understand few other details. Let's first understand how does a standard procedure looks like while writing a firmware for a specific type of hardware. What you need a compiler, which is basically nothing but a piece of software which can convert or translate your source code, which is written in a high level language like C, C++ or any other, into a machine level code which can be understood by the hardware on for which you are writing the code. For example, you are writing the software for your own native system which is running a Linux, then you simply use a GCC compiler which is converting your source code written in C into the machine level code which is compatible with your hardware. But when you are writing the firmware for some microcontroller or some processor, right, you need a cross compiler or so-called tool chain, which is nothing but a compiler only, but it converts or translates your code base into the machine code of that target architecture, not the one on which you are writing the code. So you write the code into the your preferred language, C, C++ or any other, and you use that cross compiler to translate your code into the binary which can be flashed on the target, and you can run it. Now this is a very basic process. Now let's just relate it with the a microcontroller firmware. Let's take an example of STM32. So how do you write a firmware, or how does a firmware development flow looks like for the STM32 kind of microcontroller? You would need a toolchain, as we talked. So toolchain is provided by IDE, which is generally comprises all the tools, editor, all the other flashing tools which are required to have to provide you a complete development environment to develop the firmware for the particular hardware. In case of STM32, we have a cube IDE. So here your cube IDE provides you a cross compilation tool chain, an editor in which you can write the code in the C language or C++, and some other tools to flash the code which is generated from this IDE onto the STM32 board. So it also provides you a set of other tools like CubeMX, which is nothing but it allows you to configure your hardwares on the STM32 using their framework, on which you can configure the hardwares like hardware peripherals, basically like UART, GPIOs, I2C, the way you want it in your use case. Once you configure it, the CubeMX generates the code requires to initialize the hardware or configure the hardware in that specific manner. Then generated code gets integrated with the application that you are writing, and that the final output of that entire firmware will be the hardware configuration and the logic that you have written on it. And the same file which is generated using the STM32 IDE can be flashed using their tool only onto the STM32, and that piece of software runs on the STM32 board. So if you talk about a software flow or software component for a microcontroller, what it has something called a ROM code, which is nothing but a read-only memory area code provided by the chip vendor, and it gets executed whenever the power cycle or reset happens for the microcontroller. The main purpose of the ROM code is to initialize the very basic hardware to make the processor in a condition where it can load the next stage of software. It could be a bootloader also, and it can be a direct firmware as well. In case of microcontroller, there can be a bootloader, but it's purely optional. Generally, for the sake of understanding, we'll just discard bootloader as of now. your ROM code will directly load the firmware application that you have written into this IDE. So your ROM code will directly load your int main function from your firmware, and your main function will contain all the applications as well as hardware configuration code into it. There will be a single binary which will configure and initialize the hardware that you have configured, and the application code also, which is basically implementing the business logic that you are implementing. Now, if you compare this with embedded Linux, so embedded Linux is written for a high processing power CPUs. So it's not a fairly simple microcontroller which is very minimal resources and the peripherals. Here you will have a humongous sort of peripherals, computation power, and the resources that you want to manage. Writing a direct firmware on this would be difficult, and it slightly changes from the microcontroller firmware as well. Here you will also have a ROM code which will be loading your next stages of the software pieces. So here there will be, if you categorize the piece of software, there are three different pieces. One is the bootloader, which will be a bootloader for a basic hardware configuration within the processor, and which is like a internal RAM, internal DRAM, or output input output port for some very basic stuff. Then comes the operating system or a kernel, which is responsible for initializing all the resources provided by the hardware, all the peripherals that you want to use on the board, and the entities which are responsible for managing all the resources on the operating system. And the same kernel also provides you the endpoint to the user interface end as well. User interface in the sense is your root file system, or the point where user interacts with the system. You can take it as a shell or application or a browser. So all those components to which the user directly interacts is a part of root file system. So we will follow these steps that we talked about, getting a tool chain, writing the code or downloading the code, and packaging in a way in which the target is expecting. Now doing that for this bootloader kernel or root file system is not impossible, but it's very difficult to do, because it comes with a various configuration options, various way of building it, and various details that needs to be taken care while building it for a particular hardware. So what do we need in such scenario? We need a build system which can be configured easily without going into lower level details, and have an output which can be comprising all these three things with the configuration that we have provided. So Yocto is a build system which gives you a facility to build your own Linux distribution comprising with your own custom bootloader, kernel operating system, or root file system based on the configuration that you have provided. Here on the technical overview of the Yocto projects, the same definition is given. Yocto project is an open source collaboration project that helps developers create custom Linux based system for embedded products and the targeted environment regardless of the hardware architecture. So now, what are the various components that constructs these Yocto projects? Before going into the details, I will explain from my perspective. I will categorize Yocto components in three categories. One is about configuration, which is how your compiler needs to be configured, what type of architecture it should use, and what is the machine configuration, which actually tells the Yocto how and what needs to be constructed in which format. These files are generally having the extension of .conf, like local.conf or machine.conf. The second category is package configurations. So this category contains the recipe files, .bb or .bb append files. So all the packages that are there in your build system that you want to have as a part of your output of Linux distributions are following this .bb or .bb append files. So .bb is basically containing a metadata or a syntactical format for Yocto, which tells Yocto project how this package can be constructed, how it should be downloaded, how it should be built, how it should be deployed. And the third category is Yocto internal. So here it contains bitback, metadata, open embedded core, and Pokey. Bitback is a build system of Yocto which utilizes the configuration that you have given in the package configuration files, and it builds the packages that you have provided. Metadata means the information or configuration files, recipes, which is basically nothing but information which refers to a build instruction on how the Yocto should generate the output for this particular environment. Pokey. Pokey is a reference embedded distribution for testing the functionality provided by the Yocto project, because as open embedded core and the bitback, those are tools to generate an output, right? But how do you test it? So Yocto has a reference distribution which is name is Pokey, which utilizes this all the development that happens in bitback and open embedded core to make it as a baseline on which all the testing happens, and you can use it as a reference. So in the workspace directory, you will have a hierarchy like this. Workspace will contain meta layers. Meta layers will contain various recipe groups. The recipe groups will have various recipes for various packages, and each package or each recipes will have their corresponding configuration files or source files. In the workspace, generally we refer to the environment setup script. So whenever you have downloaded the code base of Yocto, now you want to initiate the build process. So first thing is you set up the environment. So there is a set of scripts that you run which setups the Yocto environment and creates a build directory for you. Now in the build directory you will have a configuration file, as we talked about, which is a general Yocto specific configuration which contains your what for which machine you want to build and what all layers you want to have it. In the meta layers, you will have various layers either defined based on category, board type, or use case specific layers. For example, Meta Pokey is a layer provided by Pokey. Meta Raspberry Pi, a BSP layer for Raspberry Pi. Meta Software Update is a layer given by Software Update if you want to implement the auto update mechanism. Within each meta layer, there will be various categories of the recipe. These categories are nothing but just a grouping how you want to manage the recipes. So there can be recipes core, recipes networking, recipes dev tools. So based on your use case or the package, the purpose your package serves, your package recipe will lying in one of these directories. Third, within the recipes group, you will have a package specific recipe, which will be either .bb file if it is a first recipe, or if you are extending a recipe to customize the default behavior of the package, then you will have a .bb append file. Here if you take an example, git.bb, so you will have the git package you want to have in your build system, so there is a corresponding file. This git.bb will contain the metadata of how you should download the git, how to compile it, how to configure it, how to build it, and how to deploy it. Same applies to the other recipes like I2C tools, core utils.bb, Linux kernel, like that. Now some of the recipes will have their own configuration file within the recipe as well, that can be required during the runtime when your package gets executed on the board. Now if you look at this, meta layers and recipe groups are basically a way of grouping various recipes in a particular group. It does not bound you with anything. It's just there to provide you a very organized way of managing the recipes. You can have any number of meta layers you want. You can give any name to it. You can have any number of recipes group, and you can give any name. Given that your Yocto build system identifies it, it should work. This is my understanding, and with this analogy, this is my understanding about Yocto project, and with this analogy you can surely have a better understanding of the Yocto project if you are starting up or you are already working into it. I hope this analogy and example help you understand Yocto project in little bit more detail. I will talk about more details on the Yocto project in the upcoming videos. So if you like this, please give a like and subscribe to the channel. Thank you.